Let's have some fun with the curve y equals 1 over 1 plus x squared. The reciprocal graph of y equals 1 over 1 plus x squared. In particular, let's find out the area between x equals 1 and x equals 3. And actually, I'm going to approximate it using trapeziums. I'm going to approximate this area by splitting it into 4 trapeziums of equal width between x equals 1. So first trapezium would look like this. And then the second trapezium, again of equal width, would look like this. And carrying on for each trapezium, going exactly the same width for each, connecting where it meets to the curve, to get these 4 different trapeziums. So how can we work out the area of each of those trapeziums? Well, the area of a trapezium is given the formula height over 2, height divided by 2, and then it's the sum of the parallel sides A and B. So for this blue trapezium, the height is actually this horizontal bit here between the parallel sides at right angles. It would be this h here. So h over 2. And then the length of A would be this y coordinate here. I'm going to call it y0. And then the height of this one I'll call next number y1. And in a similar way, the green trapezium would have area. Well, they're all equal width. So again, this height stays the same. Call it h over 2. And this length here, again, is given by the y coordinate y1. And this coordinate would be y2. Repeating the calculation for the yellow trapezium, the width is the same for each of them, h over 2. That first side has length y2, and this side has length y3. And a corresponding calculation for the last one gives the height is the same, so y3 plus y4. Good. Let's tidy this up a little bit. I can see a common factor in each of them. We've got h over 2 in each of those brackets. So let's factor out all of that h over 2. And what are we left with? Well, we've got 1y0. And then we've got 2y1s. 2y2s. 2y3s. But just one y4 there. Good, we've got a good formula there. All that remains is to find out the specific values to substitute into our calculation. Let's start off by finding out the width of our trapeziums. Well, on the x-axis, we're travelling a distance from x equals 1 to x equals 3. So the height is the total x distance, 3 take away 1, divided into 4 rectangles, which equals 0.5 in this case. So substituting that h for 0.5. And then to find each of those different y coordinates, we need to substitute in different values to get the different y coordinates. So I think I'll first work out the corresponding x coordinates for each one. We will have our width is 0.5, so add 0.5 to get 1.5, 2, and 2.5. And then we're just going to keep substituting into this formula here. When x equals 1, we get 1 over 1 plus 1 squared, which equals a half, 0.5. With this y coordinate here is about 0.5. If we were to substitute into our second coordinate, that would be x equals 1.5. And that would give us a corresponding y value. We've called it y1. Typing it into a calculator, we would get approximately 0.308. So plus 2 lots of 0.308. And then repeating with x equals 2, that would give a y coordinate of 0.2. So our y2 value is 2 times 0.2. If we put in an x value of 2.5, the y value comes out to approximately be 1.38. So 0.138. And then if you put x equals 3 into that formula, you get your last coordinate of 0.2. And then if you type that whole calculation into your calculator, I get the following approximation for this area as being about 0.473, where we've rounded to 3 decimal places. And we've succeeded in our aim. We have approximated the area under that curve by splitting it into 4 trapeziums of equal width. And what we have done there is we have introduced the trapezium rule. In our next video, we're going to generalize this method so that it could work for any curve and it could work for any number of trapeziums.